Hello.
Hello.
Hello, can you hear me?
Yes, yes, I can hear you.
Okay. So,
Recording in progress.
I share my screen. Can you see my screen?
Yes, I can see the screen. Yeah.
Okay. Okay. So, hi and welcome to the fourth day's beginners to advanced course on Google Earth Engine.
Hello, thank you. Yeah.
Okay. So, this is our full course content. We will cover this full course content within 7 days. And today is our fourth day. And today our course content will be that. So first of all, I will try to discuss how to remove cloud from satellite imagery. Sometimes when you work with the wet season satellite imagery, then you can find out some cloud and haze. So today I also try to cover this part, so how you can easily remove the cloud and get the clear imagery. It can be Sentinel or Landsat, whatever. We just follow the same procedure. Then I also try to discuss about the visualization of DEM of hillshade and swamp map in Google Earth Engine platform. So mainly here I use the DEM data for NASA SRTM, but if you have the any another data set, then you can also put the same procedure for making this hillshade map or swamp map using the Google Earth Engine platform. Then we also focus in this time the land surface temperature monitoring from the MODIS satellite imagery and make a time series chart for analysis this data. Then we also covered the how you can easily calculate the average, maximum, minimum, NDVI or any other indices. I just randomly I put here the NDVI. So you can just follow the same procedure for calculating any indices, just NDVI, NDWI, EVI or other indices. We can follow the same procedure for calculating the average, maximum and minimum result. Okay. So first of all, how to remove cloud from satellite imagery. So every satellite imagery such as Landsat or Sentinel, every satellite imagery has a band. It's called the cloud max band. Okay. So mainly we can, when you work with the cloud, removing the cloud, then we can use the cloud max band for removing the cloud and haze from our satellite imagery. So here you can see this is the one image. Here you can see some cloud, and when you work with the cloud max band, then this cloud will be easily removed and we can get the clear picture, okay, satellite imagery than others we can see. So now I also try to show you this part, so how you can easily remove the cloud and get the clear imagery, okay, using the Google Earth Engine platform, because it's very important. Because when you want to make the Landcover classification map, then you need to remove all of the cloud or haze, because when they are stay in your satellite imagery, then you cannot get the good accuracy result. Actually this cloud has a also pixel value, okay. So when you want to make the Landcover classification map, then this cloud pixel value also counted, so we cannot get the proper accuracy result, because there also the extra cloud or haze will be available here. So it's very important for removing the cloud from the satellite imagery for making the any remote sensing work, okay. So I will try to show you these things. So first of all, I just open my a new code editor. Suppose in this time I want to work for a Sentinel-2 satellite imagery and try to show you this part. So first of all, I simply import my boundary area. Suppose in this time I want to work with this shapefile for I want to work with this shapefile, suppose Dhaka city boundary shapefile. So I simply import this shapefile in my code editor. You can see it will be imported, and then I simply search here uh, multispectral. I simply use here this data set, suppose multispectral instrument. Okay, and you can see this our data set. So in this time I just, you can see that the bands cloud max band. Okay, so when you work with remove the cloud, then we can use this band cloud max. Okay, so not for the sentinel imagery, we can also find it the Landsat imagery also, we can also see the cloud max band. So mainly this cloud max band, we can see there is the 2 bit mask, you can see bit 10 and bit 11. Okay, cloud and haze, cirrus cloud we can also get here. So mainly we work with this when you remove the cloud, and we also get the clear image. Okay, so first of all I just import this imagery. You can easily simply click to import, or just copy this collection snippet and paste here.
Sir, I have a question here.
Yeah, ask me please.
Yeah. There is Q4A60 it was, and another was bit mask.
Yeah.
So another is also cloud cover is also there. So out of these three, which one should we prefer?
So mainly we can use here the cloud max band QA60.
QA60, and there is no separate cloud cover.
No.
Okay.
So mainly you use this part. So you can also see that this band will be available for the Landsat, Sentinel, every satellite imagery. We can easily find this band.
Okay, but what is the difference between cloud mask and cloud cover?
Cloud max, cloud max is that it will be pixel value will be available for the every area. Okay, but cloud cover, when you work the cloud cover, so simply when you, this is the image properties. Okay, so cloud cover, this is the image properties only for the Landsat. But you can see Sentinel, there is the no cloud cover. Here you can get some the cloud pixel percentage, cloud coverage pixel. Actually this is the factor. This is the factor for filtering your image. Suppose you want to get the cloud pixel percentage 10%. Okay, then you can get all of the 10% or less than 10% cloud image you can show here. Okay, so this is the mainly factor. Okay, so when you factor, suppose you want to factor this cloud pixel percentage 90%, but you can also get here the some cloud. Okay, then we can use here this band for removing our cloud max. Okay, so it will be max our cloud, then we can get the clear pixel, and there is the no haze and cloud. Actually this image property, you can see this image property will be different for the Sentinel or Landsat. Okay, so Sentinel, you can see there is the different properties: cloud pixel percentage, cloud coverage assessment, cloud shadow percentage. Okay, but Landsat has the also different cloud cover. We also see the Landcover. Suppose we also try to show you this. Suppose Landcover, Landsat. Suppose this collection, you can see there is the pixel. This is it's called the QA pixel. Okay, so when you work with this band, then we can use here the QA pixel. Okay, and this band and our Sentinel, you can see there is the QA60 band. Okay, but there the both of the two things will be similar. Okay, so here you can also see there is some bit 0, bit 1, bit 2, bit 3. Okay, and it has also work when you want to work this. So I just make this example, then you can easily understand. Suppose I want to work the Sentinel. So here you can see so here you can see this data set has a band you call the QA60 and bit max. So mainly when you work with this, you can see there is a 2 bit 10 and bit 11. Okay, so when you work with this, just we reduce this bit. Okay, suppose you can see this bit is 10 and 11, just we can just put our code in here, it will be less than, more less than. Okay, we can get from here. Okay, then we can just set this here, suppose cloud bitmarks equal to 0, then cirrus bitmarks equal to 0, then it will be work. Okay, so just then it will be remove all of the pixel value for the cloud, then we can get the our actual image result in here. Okay, so I also try to make this code, then I hope you understand this part. Suppose I work with this image, suppose it is in spectral, in multispectral view, I simply copy this and paste here, you can see. Then I also put here the variable name, suppose this variable name I simply put here the sentinel2 s2a, I just put this variable name, and then you can see it will be imported in this variable. And now I want to filter, suppose I want to get the filter date, for a specific time period, suppose 2016 1st January, from also get here the 2016 December 31. Okay, and then I also filter this filter metadata. Okay, and then you can see this image collection filter metadata is that, suppose I want to get the image which image will not more than cloud cover cloud pixel percentage less than 90%. Okay, so just I simply copy this name, and then I just paste here, then my operator is that less than, I simply put here the less than, suppose 90. Okay, then suppose in this time here I can get some I want to check how many images will be available here, so I simply use here the print, then s2a, then click to the use here the size function, then click to the run. Okay, we can get this the long number of images between the year of 2016 and which image this image will be less than cloud pixel percentage 90%. Okay, so you can see it will be appeared. And suppose,
Hello.
yeah,
Yes, sir. Another thing I wanted to ask is, I understood this part. Suppose if you are working with bigger regions and the console tab is showing while we click on run, it is showing something like the geometry has too many edges. So in that case, how we can go forward? Can you please discuss that also?
so I also try to show you this part.
I mean, you can tell that later after at the end of this class. I have no problem.
Okay, so later, so when you work with the many region or many vertex, your shapefile will be longer, then this it will be not directly supported in the Google Earth Engine platform, then we need to work with the some other function, then it will be okay. Okay, so here you can see I can get this image, suppose from this image I can get here the median result, I simply use here the median, then it will be clipped with my shapefile is that table. Okay, then I simply use here the map dot add layer, and it is the s2a. Okay, and then I simply remove this and focusing the center shapefile, simply use here the map dot center object, it will be table, zoom level I think is 10. Okay, then click to the run. Okay, and I also add here the visualization parameter from here. Simply click to here the true color composite B4, B3 and B2. Also increase the stress 98%. Then click to apply. So here you can see this image will be appeared, and in this image you can see, I just give this layer name is the cloud. So here you can see this image has the some cloud will be available here in this part. Okay, and also you can see this image is not clear. Okay, so some haze will be available here. So now I want to remove this. So when you want to remove this, you just show your first of all you need to make a function using your cloud max band. So in this time here I use, you can see my cloud max band name is that QS60. Okay, and it is the two bit bit 10 and bit 11. Okay, cloud and cirrus cloud we can see here. So now we just use this band for removing the all of the cloud and the haze pixel value. So for this, first of all I take a first, suppose when I create the function, we already know about that. So just I use here the keyword the function. Okay, so this is the function. Then I provide here the function variable name. Suppose in this time I simply use the variable name is the max to clouds. You can use any variable name, max to clouds. Then I simply put here the parenthesis, and between this parenthesis just put here the element name. Okay, after this I simply use here the curly bracket, and between this curly bracket I just put here my argument. So first of all I need to select my cloud max band. Okay, so my cloud max band is that I simply take a variable, and after this I take a variable name is the QA. You can use any variable name. Then I just use here my call my element name. So in this time my element is the image. I simply put here the image, then use here the select function. Okay, and after this I already know about how my, you can see my band name is that it is the QS60. I simply copy it from here and just paste here. Okay, so I select my band, cloud max band. So then I need to use here the cloud bit max. Okay, so I simply you can see this is a 2 bit 10 and 11. You can see 10 and 11. Just I use here the 10 and 11. I can get from here the less than 1. Okay, so I simply take a variable in here. Suppose I take this variable name cloud bit max. I can use here this cloud bit max. Okay, and then I simply put here the 1 less than 10. Okay, because this 10 it comes from our the 1 bit 10, and then another, suppose another is the cirrus bit max. I simply use here the var, then simply put here this variable name is the cirrus. You can use any variable name. I simply use here the cirrus bit max, and it will be, this bit is the 11. I simply put here the 1 less than 11. Okay, and then we need to add, we need to set here the every bit max equal to 0. Okay, so here you can see now I want to just set, this is the this is our band name QA. So this QA bands has the two things. First thing is that cloud, second thing is the cirrus. So I set the two things, and now I want to set here the two things will be 0. I set that is the 0. So it means that it will be remove all of the pixel value, and it is the totally null. So then we can easily remove all of this pixel value of the cloud and haze. Okay, so now I simply use a variable. Suppose this variable name is the max, and in this max variable I simply call my band name. My band name is the QA60. It will be stored under this variable QA. So I simply use here the QA, and then I just use a function. It's called the bitwise AND. So this is the function bitwise AND. Sorry, so it will be bitwise AND. Okay, and then I just simply use my cloud bitmax, this variable, and I set here equal to 0. So I simply use here the equal to 0. Okay, and I also add the another things for the bitmax. So I simply use here the AND function, and then simply call my band variable name QA, then use here the same function bitwise AND, and then just put here this the Cirrus bitmax. Just I put here the equal to 0, equal 0. Okay, so here you can see, first of all I select my specific pixel value band, cloud max band. In here I use the Sentinel 2 satellite imagery, so that's why I put here the QA60. When you use the another thing, suppose you want to use here the Landsat, then you can use to add to here the another name, another cloud max band name. Okay, then you can set here the, you can see this is the bit number 10 and 11. 10 is the cloud and 11 is the Cirrus. So I set this value, then I just use here this call this variable name cloud bitmax and set here the pixel value equal to 0, and Cirrus bitmax I simply add here the same equal to 0. Okay, I hope you understand this part. Any question?
Yes, I understood, but the reason you're using dot and function, that one, can you please repeat? And the reason for using 1 less than 10 or 11.
So here you can see this is the 10, this is the 10 bitmax. So here I simply use get from here the 1 less than 10. So it means that it will be showing the result for the minimum cloud and Cirrus. Okay, then I can get here the minimum, then I simply put here the equal to 0. You can see I simply put here the equal to 0. Okay, so that's why it will be showing the, it will be max with the cloud bitmax and Cirrus bitmax, and then it will be set the 0 pixel value. So that's why I simply use here the equal to 0. And bitwise, and if this is the function, it will be connecting with your band with your any specific value. Here I can put this value cloud bitmax, I can get this value minimum. Okay, then I simply use here the equal function, then I set here the 0 both part. And this 10 and 11 is our bit number. So here you can see 10. So I can get from here the less 1. So that's why simply I use here the 1. Okay.
Okay. Yeah.
Okay. So now I just use here a return function. So you can see I make this max, and now I want to add this max with my element name. So then that's why I simply use a function. It's called the return function. So I simply use here the return, and then I simply call this my element name image dot. I want to update this max, so I simply use here the update max function. Update means that now I want to add this which I created this marks. Now I want to add this marks which in stored here the 0 pixel value be, for the cloud and cirrus. So now I want to add this with my whole collection with the, this is the image, this is the element. Okay, so I simply use here the update marks. Okay, and you can see this value is that marks. So here I already updates an image, you can see. So in this time I simply copy and paste here this variable name, so because it will be added with this image, with this element name. Okay, and now you can see I created all of the things. This is my function, and now I want to add this function with my collection. Okay, this is my collection. So for this we already know about that. When you want to make a function and now you want to add this function with your whole collection, then we need to add here the map function. So map is a function, it will be connecting with your function. This is our function which I created, and now it will be connect with my whole collection. Is that you can see this is the whole collection, it will be included here. So I can simply use a function, it's called the map. I simply put here the map. Okay, and then just copy this variable name and paste here. So now this function, all of the functionalities will be added with my collection. Okay, so I simply use here the map and then paste here this variable name of this function. Okay, so now it will be work. So I just simply click to the run. Okay, so you can see now this image will be more clear. When you work with this, we can get some cloud in here. In here we also get the some cloud, but in this time you can see there is the no cloud will be here. Okay, so this is the things for when you work with the remove the cloud and haze and get the clear images for the Sentinel-2. You just use this code for making this. Okay, just make this function, and now simply use the map function for adding your function with your whole collection. Okay, so now it will be okay. So now we can simply use for this image for making the Landcover classification or other remote sensing work. Okay, and now we can get the good accuracy of this any map, any remote sensing work in here. Okay, any question?
No, not as of now.
Okay, okay, and I also provide you this code, so you can also practice for this code with your another region, and you also take the image for the wet season, then you can just use this function, then you can also get the understand better. Okay, okay, so I will go to my next slide. So in this time I also try to discuss about the land surface temperature monitoring using the MODIS satellite imagery. So mainly when you work with the land surface temperature, we can use here the two satellite imagery, MODIS, as well as also if you want you can also use here the Landsat. Okay, so MODIS this resolution is not so good than Landsat, but Landsat, when you work with the Landsat, we need to add the another algorithm. But MODIS, this dataset already provided the Google Earth Engine data catalog, so it will be not for the need to write the details about the algorithm, because this dataset already provided the Google Earth Engine platform, but Landsat dataset is not provided. Okay, so that's why you also need to write this code for algorithm for making the Landsat satellite imagery using the land surface temperature monitoring. But in this time we just use the MODIS land surface temperature monitoring dataset and make for our specific region and try to show you the time series chart. Okay, so you can see this is the land surface temperature map. So we also try to use here the make the land surface temperature monitoring chart like this. We also downloaded this data. Okay, so for this I open a new code editor. So in this time, suppose I want to make the land surface monitoring for the specific region. So I already uploaded my this shape file in here. Suppose in this time I also work with the Dhaka district. So I simply import my shape file, this shape file. Okay, I work with the shape file. I simply import the shape file and get this layer name is that ROI. Okay, and then in this time I also need to import my collection. So my collection is that MODIS LST. I simply search at the MODIS LST. Okay, so here you can see the different types of MODIS dataset. So in this time I want to use this dataset radar and land surface temperature. You can see 8 day. This is the interval. This dataset interval is the 8 day. So every 8 day it will be provide this data or image. Okay, so this is the dataset for the global 8 day. Okay, so here you can see this is the band. Okay, so I just simply click to import, or if you want you can just simply copy this collection snippet and paste in your code editor. So I simply copied and paste here. So now this dataset will be imported in my code editor, and I provide the variable name. Suppose this variable name is that I simply put this variable. This name is the MODIS LST. Okay, you can use any variable name. So now you can see it will be imported my dataset, and then I also need to add here the specific time frame. Okay, so we already know that when you work with the time, then we can use here the filter date function. Okay, we already know about this function. And now I also try to show you that another function. It's called the date range. Okay, and when you want to suppose first of all I define a date. Okay, then I also want to get here the 2 years, 3 years, or 2 day, 3 day. Okay, just you put this value, then it will be automatically showing this collection within this time. Okay, suppose I simply take a variable. Suppose this variable name is that start. Okay, you can use any variable name. Then I simply use a function. It's called the EE date. Okay, and then suppose in this time I simply put here the EE date will be 2015 1st January. Okay, so this is my EE date, and now you can see this is my start date. And I also make a function. This function provide me date range. This date range can be year, month, or day. Okay, so for this I take another variable and give this variable name is the date range. Date range. And after this I simply use a function. It's called the EE dot date range. Date range. Okay, and in this time we can see this argument is that start. First of all you need to provide here the start date, then in date, and then time zone. Okay, so I put here start date. You can see I want to add here this start date like this, which date I provided in this time, and I provide this variable name is the start. So I just simply use here the start. Okay, and I want to make the in date. In date will be that it will be start from the start date, and I simply put here the advance. Suppose I simply use here the start, it will be start from the start date. Then I simply use here the advance function. Advance, you can see this argument is the delta, unit, and time zone. So delta is the value. Suppose I want to get the start date from the 1 year, advance 1 year from this time frame, then I simply put here the 1. Okay, then I simply unit is that, I simply put here the unit is the year. Okay, and it means that you can see it means that it will be start from the year of 2015 and end will be that 2015 December 31. Okay, because I put here the 1 year. Okay, so it will be completed the full year of 2015. Okay, if you need the 2 year, just you can simply put here the 2. If you need the 3 year, just put here the 3. Okay, then it will be automatically start from this time frame year of 2050 and up to this 3 year or 4 year or what you put here. Okay, so this is the thing. So if you want, I simply use here the year. If you want, you can also put here the month. Suppose you want to get this data for the, it will be start from the 2050, then you 1st January, then you want to move to the forward to the 2 month. Okay, then it will be counting the January, February, March. Okay, so I simply, when I use the month, then it will be counting between start from this time frame and counting the advanced 2 month. Okay, between start this time. Okay, then time zone is not needed for this time, it also not needed for this time. Okay, so I hope you can understand this part. Any question in this time in here, start date and date frames between this function?
No question.
Okay, so from these questions, suppose in this time here I advance 1 year, so I simply put here the 1 and just put here this month is that year, this unit is the year. Okay, so this is the function, and mainly we can use this function for the date range and date, and also use here the advanced function. Okay, so now you can see here I already put my image collection. So now I want to select my specific band. So in this time you can see this data set band is that. So here you can see this data set is the day land surface temperature, only day land surface temperature. Okay, and this is our band, and from you can see this is the mean and max pixel value, and this unit is the Kelvin. Okay, you can also see this is the scale factor, and we already know about the scale factor when you work with the NDVI. We can see when you work with the NDVI and reprojected our value, then we can just multiply with our whole collection with this scale factor. And in this time we also do for the same, when you want to reproject it, we can just multiply with this value. Okay, and then we also convert this the Kelvin to degree Celsius. Okay, so in this time I just select my specific band, so I just copy this band name